seeing the title of the video only, you understood that this video is extremely important for class 10 students especially, because here we are going to talk about the project given by the boards to certain schools, many schools actually. And this project is about how to use the Orange data mining tool in terms of project cycle. So here in this video I'll tell you very clearly each and every step. I'll explain how to do, so that while you are doing the project you do not have any doubt. And whatever you have learned in theory, okay, whatever you have learned in theory, you'll see the implementation here, and you're never going to forget the theory after this. And the people who are not having Orange data mining project as like given by their boards in school, okay, so they also, if you watch this video, whatever projects related to Orange you get from your school, that you can solve if you see this video. It will be very clear to you, and your theoretical concepts will also be replenished. So make sure that everyone is watching this video, okay? I'll start from the very scratch, that is how to install Orange data mining this tool in your computer. But if you have already installed, then you can go to this timestamp down below here. So now here I'm in my Firefox. Let us write Orange data mining tool download. Here we have it. Okay, now here we have orangedatamining.com, this link you click. And after that, here you have for Windows you have this, and for Mac, if you have Mac, then you have this, okay. Accordingly you download, okay. For me, I have Windows, and here also it is there that like there is a suggested download portion. So I have already installed and downloaded Orange using this link. If you click here, it's saying, would you like to save this file? You save, then it gives you a .exe application, then you click on it, you install, okay. So I have already installed it in my system. Here you can see, oh my god, what is this? Wow. Okay, here we have Orange, okay. As you can see on the top, we have this little guy, okay, Orange. So you click here, it's opening, as you can see. Click on new project you want to create. Now let us save this project. Let us save this project using penguin.ows. OWS is the extension for saving this Orange project. The full form is Orange Workflow, okay. And why have I saved it with penguin.ows? Because we are going to deal with a project which has a question related to Penguin that will come to what is the project, okay. So let us save this penguin.ows. This project is saved. Now what is our purpose? What are we doing? Why are we doing? Right, okay, I understand the curiosity. Okay, so here I have opened File Explorer, okay, where I have saved my penguin.ows. That folder I have opened, and you can see that here I have a dataset folder, and inside this dataset folder I have some CSV files, okay. 2 CSV files I have, and both of them will open in Excel, okay. So if I open the Penguins train CSV, so here I have opened the Penguins train CSV, okay. You can see here we have 6 columns, okay. That is species, island. The whole thing is based on penguins, okay. We are doing a research on penguins. We have species, island, culmen length, culmen depth, flipper length, and body mass. So total we have how many? 6 columns, and we have I guess multiple rows we have here, okay. We have 345 rows in total, okay. Now here we have 3 species, okay. We have Adelie species penguin, you know. Then we have I guess we have Chinstrap penguins, okay. And then we have Gentoo penguins, okay. and then we have 3 islands where the penguins live, that islands. Okay, so one is Torsigen, Bisco Island, and there is one Dream Island. Okay, 3 islands and 3 species are there. Now each penguin has its own identity, like each row, this row, if you take this row, is for one penguin's identity. That one penguin, I have a penguin, that penguin is from species Adelie, lives in island Torsigen. Culmen length is, culmen means the upper body part, okay, upper body part width. So culmen length is 39.1 mm, culmen depth is 18.7 mm, flipper length is 181 mm, body mass is 3750 grams. Okay, so this details are there for 344 penguins. Okay, what is the job of the model that we are building? What is the job of that? So we will give this penguins train data set to our orange data mining tool, and from the training data set it will study. Okay, it will study like what kind of species lives in what kind of island, what flipper length, what body mass, what culmen length and depth they have. So it will study all the features of a particular species of penguin, and it has to predict, like when we give it in the testing data set, it has to predict the species of the penguin by seeing the features. The model has to predict the species of penguin by seeing the features. If you begin from the beginning, first what you need to do, you have an empty thing right over here. We have to import our training data set and testing data set first, right? So if you open this window, you will get this section. So you click on data, and here you will get an option for CSV file import. So you click on this, and here you will get CSV file import, and here also you click, and from here you can import that CSV file, the penguins train CSV file. Okay, you click on here, import any file. Here you have your file explorer window open. Now you also accordingly you have to choose your data set. Okay, I have my data set here, penguins train. Okay, here you can see all the rows and columns, all the information. Okay, here we have total 345 rows as you can see, and 6 columns. So it is perfect. Let us click on OK, and here you can see the info, 344 rows, 6 features. That is it. Let us rename this. It is named as CSV file import. So right click, rename, and we can rename this as train data. Okay, we name this as train data. Now we have to also import the test data, right? The testing CSV file that we had. So again, drag this CSV file import button and click on this. You select from here import any file. Then you again have this thing open. Let us select penguins test.csv. So let us click on OK. We have 344 rows, 6 features. Okay, let us close this and right click, rename. We rename this as test data. Got it? What I told you before about the project, what we are going to do and everything. We are going to what is our model going to do? Predict the species by seeing the features. That was the problem scoping part of the project cycle, right? And here we imported the data. Okay, we studied the data, how many rows, how many columns are there. Okay, what is the data all about? So this was the data acquisition part of the project cycle. Now we are going to do data exploration. Okay, we are going to explore the data. If there are any missing values, how do we know if there are any missing values? For that we need under this data section only, we will get a button feature statistics. Drag it here. Okay, now in feature statistics, if you connect the train data, okay, so our buttons will have 2 sections generally. This will be the input part, this bracket right over here, and the outer bracket will be the output part. Okay, so connect train data's output to feature statistics input like this. Okay, you just drag. Okay, now if you click on feature statistics, initially this is what you will get to see, a very gray and boring thing. And here you can also see that In total here we have 6 of features: culmin length, culmin depth, flipper length, body mass, species and island. Okay, and why is do you know why is this named C, and why are species and island named as C and the others as N? Because species and island are categorical data, and that means qualitative data, and our culmin length, depth, flipper length, body mass, these are all numerical data. So N for numerical, that means they're quantitative data. If you see your this thing, okay, if you see this, our Penguin strain CSV, you will see that this all this they are having numerical data, quantitative data, but our species, these are having qualitative data, right? Categorical data. There are 3 categories here. Under species you will get 3 categories: Adelie, Chinstrap and your Gentoo. And under island you will get Torsigen, Bisco and Dream. So these are having categories. Okay, that was it. Feature statistics, you will also get to see there are missing values. In culmin length we have 2 missing values, in culmin depth 2, so in flipper length we have 2 missing values, body mass we have 2 missing values, in species we have no missing values, in island also we do not have any missing values. Okay, so what are the missing values they are talking about? So here you can see in the Penguin strain CSV, in culmin length, culmin depth, flipper length, body mass we have not available. Okay, we have NAs. Okay, that is why it was telling you that in these 4 numerical data sets we have 2 missing values, but here we have only 1, right? So if you filter this, so if you filter your culmin length by NA, you can see that there are 2 rows, row number 5 and row number 341, where these 4 numerical data sets, okay, they have got NAs, okay, in 2 rows. Okay, but species and island they have values. Species has Adelie here, Torsigen here, Gentoo here, Bisco here. So here what you are seeing, that only is displayed. In culmin length you have NA, in culmin depth you have NA, in flipper length you have NA, in body mass you have NA 2 times, that is why missing 2. Okay, but in species you have values, that is why 0. In island also you have values, so 0, no missing values. And here you have the mean of the values. Mean means your average of all the total 344 values of culmin length. You have this mean 43.9219. For culmin depth you have this value, for flipper length you have this value, for body mass you have 4192.57. this is your mean. Then mean means the average. Okay, mode means frequency, the highest frequency. Like you have this data set of all the numbers of in culmin length. In culmin length if you see, okay, in culmin length if you see, you have all these values. Now out of all these values, the value which has the highest frequency, okay, that is your mode value. Okay, that means out of all this, it's saying that the mode is 41.1. that means the value 41.1 has occurred in the data set the highest number of times. So if you copy this data set, if you just copy this data set and I paste it in my notepad++, if I paste it here, if I find over here 41.1 and if I count is 7 matches in the entire file. So 41.1 has occurred for 7 times, and that is the highest number of times any value has occurred. Okay, so 41.1 is going to be your mode. Then is your median. Median means the middle value of any data set. Of any data set there is a middle value, right? If you have a data set of 5 numbers, okay, so this one is going to be your middle value, right? You can easily pick out from odd numbers. But what if you have 4 4 numbers if you have, then what is going to be your, there is nothing in the middle, so what is going to be your median, the middle value? So here in the middle you have these two numbers you have, right? So the numbers in these two position, I guess this is one, if you this is the first, second, third, fourth. So second and third, these two are the middle, right, of the from the even numbers. Now these two are the middle, and whatever value or number you will have in these two positions, the mean or the average of these two numbers is going to be your median for the even numbers. So for odd numbers you can easily identify this is the middle value, this is the culprit, the middle finger, and for odd numbers it is going to be these two are your middle values, the average of these two numbers at this position, that is going to be your median. Okay, then you have the minimum value, the maximum value, and the missing value. Okay, now what is this distribution thing? Distribution here means, see, in island you have 3 values, right? Pisco, Dream, and Torsigen. So you have 3 bars for island. You in species also you have 3 values, Gentoo, your 3 unique values. We have many values, we have 344 values, but 3 unique values. Okay, so in species you have 3 unique values, Gentoo, Chinstrap, and your Adelie. These 3 are the species, unique species. For Kalman depth, there are many numerical values, so it is not fitting in the screen, right? For Kalman length you have many numerical values, so it is not fitting in the screen. Flipper length also you have many values, body mass also you have many values. So here if you have an option over here, color, which is set to none by default. So if you select species, this will become colored. So here now for species you have blue as Adelie, red as Chinstrap, and for Gentoo you have green. Okay, this is the color scheme that is assigned. Now Adelie represents blue, and Adelie has the, like, Adelie's bar is the highest, then comes Gentoo, which is higher, and the lowest is Chinstrap's bar, right? So Adelie, in this entire data set, Adelie has occurred the most. How to know? What is the proof that I'm having, that I'm saying all of this nonsense? If I replace the data set over here and I want to count that how many times has Adelie occurred. So Adelie, if you find this, I'd find what? Adelie. Okay, count. So you can see 152 counts for Adelie. Now for Chinstrap 68, and for Gentoo 124. So for Adelie you have 152. For Gentoo you have 124, a little lower than Adelie. And for Chinstrap you have 68, the lowest, that is only shown in this bar, right? And here the mode means the highest frequency. So Adelie has the highest frequency here, that is why the mode is Adelie. And a categorical data set cannot have a mean and median, right? Then in the island column, okay, you have the mode as Bisco. That means Bisco has the highest frequency, so the highest bar will be Bisco. So this first bar that you are seeing, that is Bisco. Now why is it blue and green? Understand this. In this data set, whichever row will have Bisco, that is shared by mostly Gentoo, and a little bit of share is by Adelie as well. If you see here, for island, if you select only, if you filter Bisco only, you select only Bisco, you can see all of this is Bisco. Okay, now I filtered only Biscos from here. If I select this and I paste it here, you can see the count of Adelie is 44 here, and if I write Gentoo, the count of Gentoo is 124. So the count of Adelie was much lower, right? Here that is only saying in whichever row you will find Bisco, in that rows you will get Gentoo mostly, and you will get a little bit of Adelie, but no Chinstrap was seen. If you see this data set, we filtered all the rows which has Bisco, but we never found that it is shared by Chinstraps, right? It is only shared by mostly Gentoo and little bit of Adelie. And here you can see that there is an island which has the lowest frequency, lowest of all, and that is only blue. That means that is only shared by Adelie, right? That is only shared by Adelie. What is this row? Let us find. We'll find it by ourselves. Okay. Now here we had only filtered Bisco. If you filled instead of Bisco, oh my god, if you instead of Bisco, if you filtered Torsigen, oh, we have got. If you see, all the rows which have Torsigen, they have been filtered, and those rows only contain Adelie. You can see there is no other species here. If you had selected Dream, okay, let us select Dream. In Dream, you can see we have Adelie, and then we have mostly Chinstrap. Yeah, we have Adelie and we have nearly equal amounts of Chinstrap as well. But here we do not have Gentoo. Let us check. Okay, so this one is Dream. Okay, this one is Dream. How we can understand that it is occupied by only Chinstrap and Adelie, as you saw, right? It has no Gentoos. There is no green in this bar. And we had also seen Island Torsigen. If you see Island Torsigen, whatever row, in whichever row there is Torsigen, it is occupied only by Adelie species, right? There is no other species. If I make it shorter, you can understand. There is mostly, see, it is all Adelie. It is all Adelie. I'm not lying. This small bar, this one is Torsigen Island, because in that island we only have Adelie species. And then it is same for Kalman depth, Kalman length, flipper length, body mass, everything. I hope you understood. Now if you, here we had selected the color in respect of species. If you select it in respect of island, then all the islands will have the unique colors. That means, okay, this is again going to be interesting. For island, now Bisco has got blue color, Dream has got your red color, and Torsigen has got your green color, right? Previously in the species you saw that this portion, this was Adelie. Okay, so here also this is Adelie. Now Adelie, in whichever row you have Adelie, it has a nearly equal amounts of Bisco, Dream and Torsigen. That you can understand from this part. Now in species, if we select only Adelie, what we can do is we can copy this island column and we can paste it here. And what we can do is, if you select Torsigen and you find, if you get the count, Torsigen has 52 matches, 52. Torsigen has 52. Then we have Bisco. Bisco has count 44. Okay, it is very near. And then we have Dream, 56. It is very near. Okay, so both, so three of them are nearly equal. So that is why here you see equal amount of Bisco, Dream and Torsigen. Okay, nearly equal amount of Bisco, Dream and Torsigen. So in whichever row there is Adelie, that row is nearly equally shared by Bisco, Dream and Torsigen. So here in species you have this chota thing. What is this chota thing? Let us go to species. This one is Chinstrap. Okay, so what is it saying? That in whichever row you have Chinstrap, that only has Dream. Let us check. Let us check. In whichever row we have Chinstrap, that only has Dream. Yes, that is what we can see. All the rows have Dream, right? All the rows have Dream. That is why this is fully red. And now there is a third one, which is Gentoo. This bar is Gentoo. Now what it says, that in whichever row you have Gentoo, that row has only Bisco. Is it true? Let us see. In whichever row you have Gentoo, that row only has Bisco. Yes, that row is only having Bisco. So it is all blue. Okay, I hope this is clear to you. This was very important to understand. Okay, so this was it. Now we have missing values that we saw. Okay, while exploring the data, that we saw that we have missing values. How do you remove these missing values? Here in this data set, you only have 2 missing values. That's why you can manually also remove them. But what if there are many missing values? You have to find and find and find, and then you will delete it. Not possible. So what we are going to do, in the transform section, okay, you will have impute. Okay, where is impute? Yes, here is impute. Drag this impute button. Now train data's output will be connected to the input of impute, and impute's output will be connected to feature statistics input. Okay, this is how the change will happen. Okay, now from the training data, whatever data you are getting, that will be imputed. If you double click on impute, you will get this. Okay, now click on this button, remove instances with unknown values. So whatever unknown values, the NA values which you had, that will be removed. How can you understand? Again click feature statistics. If you double click, you can see the missing values have become 0. The missing values have been removed. Okay, the missing values have been removed. Now our next job is to select a target variable. In this, yes, in the transform section only, you will have a button, select columns. Drag it. Okay, select columns you have dragged. Now the output of impute you connect to input of select columns. Now if you click on, it will tell you that you have to select the target. Now what is going to be a target? How to select the target? Why have you dragged select columns? So if you go back here in the train data set and you clear all this nonsense selection that we have done. Okay, so what was our initial problem in this stage problem scoping? What have we discussed? That I want my model to predict the species based on all this island length and depth and length and body mass, all of this features. Based on this, I want my model to detect the species. So species should be my target variable, right? Now I have dragged the button selected columns because species is a whole column. So in my select columns window, I have to drag this species category to the target. Okay, so I've set my target. Now close this. Now after you have selected the target variable, now what you will do is you will split your data. You remember in evaluating models chapter, if you have seen that video, then you will remember there is a train test split. That section is there. There is a train test split where you split the data by 80-20 or by 70-30 into training data and testing data. Okay, in one the model will train itself and then it will test on it. Okay, so you need to divide your data as well. You need to split your data as well. How to do that? So in the transform section only, you have a button data sampler. Drag it. Data sampler you have dragged. Now connect select columns and data sampler like this, and you click on data sampler. Now you will have different sampling types. Like you can do the sampling using a fixed proportion of data. Like I want to split it using 80-20, like 80% training data and the rest will be your testing data. So drag it to 80%. Yes, 80%. Now if you click on sample data, you can see here we have 274 and 68. That means if you add 274 and 68, it will give you 342. Why 342? We have 342 rows, right? Because first we had 344 rows. After there were 2 NA values which have been removed. So now there are 342 rows. In this 342 rows, the 80% of it, that means 274 rows, have been separated as training data, and the other remaining 68 or the other 20% that has been separated as your testing data. Got it? So that kind of splitting has happened. Now there are other sampling types as well, like fixed sample size. You give it instances like so here 171 has been entered, so I can enter 45 as well. 45 if I enter and I click on sample data, so the training data has 45 instances or 45 rows, and the rest is 297 rows are left, so that will be your testing data. Okay, this way also you can do. If you give here 89, then sample data. So that way it is splitted. Okay, so there are many other types, but we are going to go with the fixed proportion of data, which is 80%. We are going to split it by. Okay, so click on sample data, close it. Now how will you see how your data has been split? How will you see that? So to see the information of the data, you go to data again, data section, and you drag this thing that you have, data info. Where is that? Yeah, data info. Drag it. Connect it with data sampler. If you click here on data info, you can see name Penguin strain, size is 274 rows, 6 columns. Features found 1 categorical and 4 numerical. Now if you have 1 categorical and 4 numerical, that will give us 5 columns, but we had 6 columns. We had 6 columns. That means 2 categorical and 4 numerical. But why is it saying 1 categorical? Because this species column we have set in target variable, so that it is not counting. It is counting from island. Island is your 1 categorical data that it is talking about, and the remaining 4 are your numerical data. So that is why it is saying features 1 categorical, 4 numeric. Targets, what is the target? Categorical outcome, that means species, with 3 classes, Adelie, Gentoo and Chinstrap. So what you can do, if in select columns, if you go, instead of species, if you set your target as column depth, okay, that means that numerical data, and you click on close, and then you go to data info again. Sorry, if you go to data info again, then here you can see features are 2 categorical, that means island and species, and 3 numeric. Why 3 numeric? Because column depth we have given in target. That's why that is not counted, and target is numeric target variable. Okay, but we are not going to do that. So select columns, remove this, enter species in target. Okay, but this is only the data sample. Okay, this is only the training data part, 274 rows. How will you see the remaining data? Again, drag data info. Okay, connect it with data sampler, and here you have to click the connection. Now this connection that has been made, click on this. Here if you hover over this connection, click on it, it will be deleted. I want my remaining data to be connected to data info 1. Okay, so if I click on OK here, you click here, you get the size as 68 rows. That means the remaining data that we had, the 20% of the data that we had. Okay, that we can see. And here in this one, you can see 274, the 80% one. Okay, now after we have completed our data exploration step, now what is left? Now we have to create our model, data modeling. So what model can we do? You click on model, and here you will get a tree model. Drag it here. Okay, drag the tree model here, and you have to connect it with data sampler. Connect it with data sampler, and here you get your tree. Make sure all this is they're checked. Okay, make sure all this is checked. Apply, and now you have created your model. You can also do one more model, that is random forest. Drag random forest here, and you can connect it with data sampler. Now we have created our model. Now what to do? How to evaluate the model? So for that, you go to evaluate, and you drag test and score. Okay, and you connect tree with this, and you connect random forest also with this. Okay, and you have to also connect data sampler with test and score. Okay, now if you click on test and score, you will get, in evaluating models, what you have learned, there are certain classification metrics, right? So this is classification accuracy for this one. Okay, and then you have F1 score, your precision, your recall. Okay, you have a correlation. So for tree model, this is your score for accuracy, for F1 for precision, for recall, and for random forest model, this is your score. Okay, so for the target, you can particularly select Adelie as well. For Adelie, what is the accuracy, what is the condition of the scores? For Chinstrap, what is the condition of the scores? For Gentoo, what is the condition of the scores? That you can also see. And if you want to see for all the average for all the classes, then you can select the none option. Okay, so this is your test and score. Now I wanted to do actual predictions. Okay, this to what it learned from the training data, it performed on the testing data, it was just learning. Now I want you to actually make predictions, real predictions, predict the species. Okay, how to do that? If you see, till now we have done nothing with this test data, it is kept like that only. So in evaluate section, you have another the second option, which is the second button, which is predictions. Drag it, drag your predictions here. You connect your model random forest with this. Okay, connect your model. I want to check what the model random forest predicts. Okay, how it is predicting. So this is my model which is connected to predictions, and connect this to the test data. Connect predictions to test data as well. Okay, otherwise how will it get the data set? Okay, on which to on what will it predict, right? So connect it, and now if you click on predictions, this is the magic. So in this one, okay, random forest, what it is doing, it is predicting the species based on the features, and this is the actual species. Okay, so what the model is predicting, that also it is written, and what is the actual species, the actual answer, that also is there. So you can see that it is correctly only predicting. Okay, it is predicting Adelie. This is all correct, all correct. It has not, here we have got a wrong one. Okay, here we have got, it has predicted Chinstrap, but the actual species is Adelie. Okay, so this one is wrong, and all of this is wrong. My god, it has, for the actual species, which is Chinstrap, it has predicted Adelie only. Oh my god, all of this is wrong. The whole Chinstrap group, it has done wrong. And here again for Gentoo, it is correct. Yeah, it is correct. So what you can see here, that the random forest model is so pathetic that it is predict for Chinstrap, where the actual species is Chinstrap, that it is predicting as Adelie. It is incorrectly predicting Chinstrap as Adelie. Okay, the whole Chinstrap group, it is predicting as Adelie. So we cannot use this model. This model is predicting one species incorrectly only, the whole group. So what we can do, we can connect, we have another model which is tree model here. So if you connect tree model to predictions, and then you click on predictions, you can see that the predictions given by tree is also present here. So tree is correctly predicting Adelie, but here it has incorrectly predicted, okay, Adelie as Chinstrap. No problem, it's going down. Here again a wrong one. What I want to see is, has it predicted the Chinstrap as Chinstrap correctly, or that it has done wrong? Yes, it has correct. So actual species Chinstrap, it has predicted as Chinstrap, and this is for all. Okay, so it has correctly predicted the Chinstrap group, whereas in random forest, it was totally predicting Chinstrap as Adelie. The whole group was predicted wrong. But in tree, it is making some mistakes, but at least it doesn't predict one whole group as wrong, right? So tree model is better than our random forest, right? That we can know from here. So this is how our model was making prediction. So that was it for this video. I hope you understood how this data mining tool works. Orange, okay, it's a fantastic application. I found it very nice. It is very interesting. It was fun connecting the dots and everything. If you face any problem while doing this project, please